We've already done the hypothesis testing for one mean, and then we use the t-test, and then you know how to do that. We did that with examples, we did that manually, and also we used StatCrunch. Today we are going to look at the hypothesis testing for the difference between two means. So usually we write the null hypothesis as this sign here is just to represent any arbitrary number. So for example, it could be 0, it could be 2, it could be anything. Is that okay? And then the alternative hypothesis depends on the problem. Bless you. And then we learned about whether we should use the z-test or the t-test. Here we are focusing on the t-test. So which means that most of the problems you are going to get, you won't know the population standard deviation. So you'd be given the sample standard deviations, or you have to compute them. And then this is the t-test statistic. So for example, if the delta here is 0, it means that we are going to replace whatever it's here with 0. And then there's the sample mean for sample 1, the sample mean for sample 2, and this is the standard error. The standard error for the difference between two means is given here. This is the standard error for the difference between two means. Unlike when we had the one sample mean where the degree of freedom was just n minus 1, when we have two means, the degree of freedom is a bit complicated, and then the degree of freedom is given by this formula here. Now let us look at how to implement an example. So I'm going to do this example and do a couple of them in StatCrunch. So this example says that the resting pulse rate for a random sample of 26 smokers. So this is the sample, and then the sample size for the smokers is 26. And then they had a mean of 80 beats per minute, and then a standard deviation of 5 beats per minute. So we have smokers here. Let me use N1 to represent that. So N1 gives me 26. N1 represents the sample size for smokers. And then we are told that their mean is 80. So we can also see, you can use X bar 1 or Y bar whatever as the same thing. 80. And then the standard deviation we're given is not the population standard deviation. It's a standard deviation based on the sample of this 26. So that is what? S1, which is what? 5. Now we proceed. Among 32 randomly chosen non-smokers. Among 32 randomly chosen non-smokers. So now we have another group, which is what? Non-smokers. And then their sample size, I'll use N2 to represent that. Their sample size is what? 32. You can see from here. And then we are told that the mean and the standard deviation are 74 and 6 bits per minute. So we can see X bar 2 is 74, and then S2 is 6. Now we are also told that both sets of data were roughly symmetric and had no outliers. Now, the question says that, is there difference in the mean pulse rates between smokers and non-smokers. So the question says that, is there a difference in the mean pulse rate between smokers and non-smokers? So that is what we are going to do. So when you look at this problem, you can see the question is actually the difference between two groups. Is that okay? That should take your mind to difference between means. And then you can also see when we are dealing with the proportion, you see the question will clearly ask you for you to see that this is what proportion. And so since we have this, we have to check those assumptions. These assumptions, we've spoken about them when we are dealing with the one sample mean t-test. So what are the assumptions? I wrote them here so you could remember. We have randomization, and then we've already been told that they were randomly, it's a random sample, and then nearly normal, we know. So you can see from here because the data are roughly symmetric and had no outliers. So this nearly normal condition is also satisfied. And then are the groups independent? Yes, you can also see because these are smokers and the other people are non-smokers. So you can see these assumptions has been met. Now we need to write our null hypothesis. So H naught and then the alternative is HA. How do you write the hypothesis? The hypothesis, you can get the idea most of the time from the problem. You can see from here, the question is that, is there a difference in mean pulse rates between smokers and non-smokers? So you see a difference in what means. And we know for hypothesis testing, if you are writing the hypothesis, we write them with the population parameter. So we can see mu1 minus mu2. Or you could write mu smokers, mu non-smokers as the same thing, equals 0. There is no difference, and then mu1 minus mu2 is not equal to 0. So the alternatives means that there is a difference between the mean pulse rates between the two groups. The null hypothesis is just saying that there is no difference. That is why the difference between the means is 0. And then the alternative, the difference between the means is not 0, which means that there is difference between the two groups. The next thing we want to do is to compute the test statistics. We can use StatCrunch to do that. So what your responsibility is for you to be able to write out these informations correctly. Write your hypothesis correctly. And you should also know that you are going to apply the difference between the means. So you see how I've been able to write out my information correctly. The rest, we are going to use StatCrunch to do that. So let's open to StatCrunch. So I have my StatCrunch opened. And so we go to stats, and then we go to t-stats. It's the same thing we did for the one sample t-test. So start t-test, but here we have what? Two samples. Is that okay? Because we have smokers and non-smokers. So you go to start, t-start, two sample. And then we are going with what? With summary, because we have the summarized version of the information. We don't have the full data sets to compute the mean, the standard deviation, and all that. We have the what? We have the sample mean and then the sample standard deviation for those two groups. So we are going to work with summary. So we click on that, and then you can see what you have here is what? Sample 1 and then sample 2. You have to input the data in that order. What do I mean by that? Don't put, for example, if sample 1 is for smokers, put the sample mean for smokers, standard deviation for smokers, and then the sample size for smokers. Don't mix them. Is that okay? Like you see somebody who put maybe the sample size for smokers is 26 and then put the standard deviation for non-smokers here. It's incorrect. Is that okay? If you have to make sure that if it's sample one, input all information about sample one. Sample two, input all information about sample two. So for me, my sample one was smokers. So my sample mean was 80. You have to read this. So sample mean, mine is 80. Sample standard deviation is 5. Sample size is 26. For me, my sample 2 is the what? Non-smokers. The sample mean is 74. The sample standard deviation is 6. And then the sample size is 32. So you input this information here correctly. And then we check the hypothesis. So we can see mu1 minus mu2 is 0, mu1 minus mu2 is not equal to 0. So for example, if it's any number apart from 0, you input that number there. In that situation, we want to find that the difference, whether there is a difference or there is evidence in the mean pulse rate between smokers and non-smokers. So that is why here is what? 0. And then all we have to do is to hit compute. So when you hit compute, you can see from here, you can see you have the standard error. It's also done the degree of freedom for you as well. This is the t-test statistic, and this is our p-value. So now we can see that the p-value is very small. So since our p-value is very small, we can see that if the p-value is small, what do? We reject the null hypothesis. So since the p-value is small, we reject the null hypothesis, and then we conclude that there is sufficient evidence that there is a difference between the mean pulse rate between smokers and non-smokers. So this is how to implement the two-mean test, t-test. Let us try more examples. So I encourage you to open chapter 20 homework. So open to chapter 20 homework and let's go to question 12. So chapter 20 homework, question 12. Now, when we read this, it says that in a study conducted by some statistics students, 63 people were randomly assigned to listen to rap music by Mozart, and then no music while attempting to memorize objects pictured on the page. They were then asked to list all the objects they could remember. And then the summary statistics for each group are shown in the table below. So are shown in the table. So this is a summary statistic. So we are told that 63 people, so out of the 63 people, you can see the rap had 27, Mozart had 16, and then no music had 20. And then you can see these are their corresponding means, and then the sample standard deviations. Now, the question says that, does it appear that it is better to study while listening to Mozart than to rap music? So does it appear that it is better to study while listening to Mozart than to rap music? So the question says that we should test an appropriate hypothesis and state our conclusion. And we've been told that we should let M correspond to the Mozart listeners and then R correspond to the rap listeners. So what do you think the appropriate hypothesis would be? You can get that answer from here. Who would like to help us? So even before we begin, we can see that C is out. Is that okay? C is out because of this sign in the null hypothesis. So what do you think the right hypothesis would be? Abby, you want to help us? Why do you think it's A?
Because it's saying Mozart is like better. If it's asking if it's better than that music, so then that would be a greater than. So.
Okay. Do you all agree with that? So he's saying that because you can see from here whether it is better to study while listening to rap music, Mozart music than rap music. So you can see because of the better here, which gives him the idea that it should be greater than. And so then that is correct. Now we want to test the hypothesis. So to test the hypothesis, so we should test this hypothesis and then write the t-test. So to do that, you have to take notes. This is for what? Mozart music and then rap music. So when we look at this one here, we can see we can take our sample 1 to be the Mozart music and then sample 2 to be the rap music. I'm saying that because of the hypothesis here. Is that okay? So you should just be very careful. So it's still doing two mean steps because we are focusing on what? Rap music and then Mozart. So let's try to see if we can get the test statistic. And so before I do that, I'll try to write my N1. So my N1 is 16. My X bar 1 is 9.39. And then my S1 is 2.86. N2, which is for the rap music, is 27. X bar 2, the mean for the rap music is 10.07. And then the standard deviation for that is 3.95. So I've been able to write this out clearly. Now I can go to StatCrunch and then input the stuffs there. So we go to stats, t-stats, to sample with summary. The sample mean for the first one is 9.39. The standard deviation is 2.86. The sample size is 16. The sample mean for the rap music is 10.07. The standard deviation is 3.95. And then the sample size is 27. And so now we have to change this to be what? Greater than. Is that okay? We just need to make sure that what? The hypothesis here matches the right answer we chose from here. And then we can hit compute. So this is my t-test statistic. So I've been able to input my t-test statistic value here. And then the next one says that I should input the p-value. So my p-value here is 0.7408. And then they are asking me to state the conclusion. So to state the conclusion, is this p-value here smaller or larger compared to alpha of 0.05? You can see the p-value here is larger. And if the p-value is larger, we fail to reject. So we do not reject, and we say that there is no evidence or there is insufficient evidence. The B says that now we should compare the group that listened to Mozart music with the group that listened to no music. So that is what we want to do now. And then we are asked to create a 90% confidence interval. So we want to create a 90% confidence interval.
Professor,
Mhm.
when you have this little bold variances option on or off?
Off.
Okay, because I have it off and I was on this part and it keeps like giving me like the wrong answer. And then I went on a rounding calculator to double check and it still was giving it to me wrong for this.
You mean for the confidence interval?
Yeah, like and everything else I got from it was right, but as soon as I get here, it's wrong. So then I went on a rounding calculator to make sure I was rounding it right, and it was still the same answer and it was wrong.
Okay, let's get them, then I'll
Okay.
double check for you. Yeah. So we want to create a 90% confidence interval for the mean difference in the memory score between students who listen to Mozart and those who listen to no music at all. So, and this is the 90% confidence interval for the negative difference in the mean is, so I know for Mozart, N1 is 16, X bar 1 is 9.39, S1 is 2.86, No music, N2 is 20. X bar 2 is 14.79. And then S2 is 4.97. So let's try to do the confidence interval. So it says the 90% confidence interval for the negative difference in means. So we go here, I go to options, edit. So I have this one for Mozart already. I don't want to change that, but I have to change for the sample too. Here is 14.79. And then the sample standard deviation is 4.97. And then the sample size for no music is 20. You can see from here. And then I'll change this to be less than 0 because the question says that for the negative difference in means. So I change that. And then I want confidence interval. I change this to 90. And then I hit compute. And then I have these values here. My lower limit is negative 7.6401. And then the upper limit is negative 3.15989. So I go on here and then I try to input that. So to 3 decimal places, negative 7.640. And then negative 3.160. Let me see. Yep. So that is how to find the confidence interval.
I figured out what I did wrong. Yeah, I didn't realize that, like, I didn't see where it said the no music. I thought we were still comparing it to the rap at first.
Okay. Good. Now let's try question 9. Any question on question 12? I think this is my question. Oh, this is also part of question 12. Okay. So what do you think is the right interpretation? So I remember that when I was teaching you with the proportions how to interpret the confidence interval, it is the same thing here. You can see the intervals values here are what? Negative. And so you can see that it means that what? The Mozart is lower than those who did not listen to no music at all. So when you read, you can see that those who listen to Mozart is lower than the mean. If you get confused, you could go look at the one we did on Friday. I showed you a trick on how to interpret this confidence interval for the difference between proportions. It's the same approach for the difference between the means. We will do question 13. I'm looking at the time because question 13 is a bit difficult. It's not here, but it's just in this homework. I don't think it will appear in your test or even your final exam. But let's go do question 9 first. I think we have about 20 minutes. So Let's go do question 9. So I want you to read question 9 and tell me what you think is the right answer. So when we read this here, it says that in the July 2007 issue, Consumer Reports examined the calorie content of two kinds of hot dogs. So the meat and then usually mixture of pork, turkey, and then chicken, and then all beef. The researchers purchased samples of several different brands. So the hot dogs average this calories compared to the beef hot dogs. And then now here is the main thing. A test of the null hypothesis that there is no difference in mean calorie. So the test of the null hypothesis, there is no difference. So it means that the alternative means that there is what? Difference in the mean calories. That is what it means. And so it gives us a p-value of this. Is that okay? Now, if we have a p-value of this, what do you think we want to do? So we compare the p-value to 0.05. Would we reject or would fail to reject?
Failed to reject.
You fail to reject. Do we agree on that? Okay. Now, would a 95% confidence interval include 0? So that conclusion will depend on this. If we fail to reject, then the 95% confidence interval would include 0. Is that okay? If rejected, it means that the confidence interval will not include 0. Is that very clear? I repeat again. You all told me that we are going to what? Reject. Because the p-value is even higher than 0.5 and also even alpha is even 0.1. Is that okay? So you all agreed we failed to reject. If you fail to reject, it means that what? There is no difference in the mean. That is what it means. Is that okay? If you fail to reject, it means that there is no difference in the mean calorie content. Is that okay? And so then the question is asking you here that will the confidence interval include 0? If you fail to reject, it means that what? It's going to what? Include 0. If you reject it, it means that what? It's not going to include 0. Is that okay? So then the answer is, let's see. So you can see the no's are out. So yes, the high p-value means that we have evidence. No. So a high p-value means that what? We lack evidence. Is that okay? Right? If the p-value is high, it means there is insufficient evidence. So a high p-value means that what? We lack evidence of a difference. So 0 is a possible value for the interval, which is this one here. So that is how to answer that. I decided to pick that because I find it a bit technical. Now let's go to 13. 13 is it's kind of like the bootstrappings we've been doing, but it's a bit, so let's do that together. So I'm going to give you a minute. I think I have 14 minutes, so we have time. I'm going to give you a minute or two to spend time to read the problem. So I read. Here is the thing. It says that is it Ginkgo biloba enhance memory? So that is what they are trying to do. Does this thing that's biloba enhance memory? So that is what they are trying to what to test. So in an experiment to find out, they are trying to find out whether what this ginkgo biloba enhances memory. Do you all get that? So subject were assigned randomly to take this supplements or placebo. So their memory was tested to see whether it improved. Is that okay? The numbers reported are the numbers of items recalled before taking the supplements and the randomization test, blah, blah, blah. And then the actual difference in the mean number of items recalled is this. So you want to use the randomization test result to see if the difference in the means of the number of items recalled is statistically significant by counting the number of all trials where the mean difference is greater than this. So what do you think so we are told that G is for ginkgo biloba and then P is for placebo. What were they trying to do? They were trying to verify if this ginkgo stuff enhances memory. So, and then they used, is it the ginkgo biloba and then the placebo? So here would definitely be G minus P. Here would also be G minus P. Are we all good on that? So now let me ask you here, what do you think the sign would be here and why? So the alternative, I've clicked on the alternative. So let's do the now first. Does it enhance memory? Maybe no. So it's equal to. Is that okay? What do you think the alternative would be and why? Good. And so 0, 0. Do you all understand this one? Okay. Now we want to find the test statistic. So this is a bit different from what we did. They've given you the idea to be able to get a test statistic. They said it here, this part. It says using the random, right? This just means we are going to count to see if the means of the number of items recalled is statistically significant by counting the number of trials where the mean difference is greater than this value here. Is that okay? We are going to count the number of trials where the mean difference is greater than this value here. So let's click on this thing here. Is that okay? So you have this one here. How many trials did they do? They did 10,000 trials. You can see from here. Is that okay? So this is 10,000 trials, and we are going to count the means that are greater than what? Negative 0.993. They said it here too. I think I highlighted that for you. So by counting the number of trials where the mean difference is greater than this. So what do we need to do? Here is 10,000 trials. We were given that what? Whether it is this or below is this. So if we want to find above negative 0.993, we ought to do 10,000 minus 638. So 10,000 minus 638. That gives us a test statistic. 10,000 minus 638. So for me, in my case, it is 9362. That is how to count the mean difference that is greater than negative 0.993. Now here is what negative 0.993 or below is not 638. So we want above negative 0.993 and we have 10,000 trials. So 10,000 minus this gives you the ones that are above. So you just need to put in that statistic here. So 9362. And then that gets it. So to get the p-value, it's just going to be 9362 divided by 10,000. So in my case, it's 0.9362. So that's all. And then we want to state our conclusion. This p-value here is high. If the p-value here is high, we do not reject. And then if we do not reject, it means that what? There is no evidence. So you check that. And then that is all for question 13.